length, time, temperature, and volume, correct? Okay, all of these. And I will go ahead and write the SI units first. The SI units for mass is grams. SI unit for length is meters. And you can talk with me if you want to. For time, it's seconds. And temperature, it's Kelvin. And volume, liters. Okay, and then for mass, the non-SI units, beautiful handwriting today, it's pounds. Any other one? Ounces. Ounces. For length, could be inches, foot, mile. For time, there is no one on our side. Okay, so time is 1 unit that the entire world agrees on. Okay, that we have the same unit. So that's that. For temperature, we have degree Celsius and degree Fahrenheit. You can call this degree centigrade also. Okay, centigrade, Celsius. Celsius was a scientist who developed the scale, but we can call it centigrade also.
Doctor, why don't we use degrees Kelvin? Why is it just Kelvin?
It's just Kelvin. I don't know. Yeah, there's no degrees for Kelvin. I don't know. Maybe degrees was based on 100. I don't know. But this is not based on 100 though. Anyhow, volume, liters. Sorry about that. Liters, and for volume, the non-SI units could be gallons,
Quarts.
quarts. I was going to write Z, but it's S. Okay, and there's liquid ounces and pints and whatnot, right? Okay, so those are all the non-SI units. Did I ask you to think about why US has the non-SI units? Yes? Did I? I must have. Did you think about it? Oh no, there was so much to do in the weekend. You were thinking about Erica? No thought?
America likes to be a special stuff.
We are very special. That's true. That's true.
It's probably because by the point it was established, we already had everything set, and it'd be too much work and too much confusion to suddenly switch it from one version to the other.
What was set? You said there was. We were all set.
To SI. So there must have been at a point where we already been using the non-SI, and then we were using specific calculations, and it's like if we're using pounds.
No, I completely understand that. But the other countries were like that too. They've been using a unit for a long time, but they switched over. But you were on the right track saying that we were all set. But I want to ask you, or anyone else for that matter, what is it that we were all set about that was so hard to change? Because you're right, we were all set. I wasn't here. Neither were you, by the way. Not born yet. Anybody? What was all set? What is America known for? 100 years ago, what was it known for? Was what?
Being different than all the other
Being
countries.
different, no. No, every country is unique in their own way. So no, not that. But there was something that US was really known for. As for its industry. US is really known for its manufacturing back then. There were a lot of industries that were established. And so once you establish that industry on a certain unit, to go to another unit, it's very tough. Because not only do you have to change all the science, you have to change all the measurements, right? And so the nuts and the bolts and everything that comes with industry, all the measurements are in inches and feet and all that. So if you have to change all of that, it's too much. Okay, you just have to go to Home Depot or any kind of a store, home building store, and you look at all the units there. Everything is in terms of inches. Okay, and so it's very hard to change now. Okay, and so it's very costly, although it will be practical to get to the SI unit because everybody's following it, but it's very very costly. Okay? And if you just have to go on any kind of a highway to just see how much signage there is, right? It tells you every time, you know, this many miles remaining, this many miles. Can you imagine changing all of that to kilometers? That would be too much. So anyhow, so that's the reason. And yes, we are special too. That happens as well. Okay, and that's why people don't want to change, because we're all special. So anyhow, going back to the units over here, the mass, length, time, temperature, and volume. There are a few things that you need to know about the units. First of all, these are the units, but you can also write them in short form, so you don't have to keep writing grams every time, all right? And so we have short form for all of that. And so for grams, it is small g. For meters, small m. For seconds is S. For Kelvin, capital K. For liters, capital L. One of the things that you will know as you learn about chemistry is that it has its own language. In fact, on the reserve on 3rd floor, I have left a book there for you. It's called Chemistry as a Second Language. All right? And if you want to test it out, you're most welcome to look it through and see if that helps you in any way. I put a little mark there also for math review. Okay, so at the back, there is a little bit of math review there for you if you want to see how comfortable you are with just simple algebraic functions. But in any case, what I'm trying to say is that it has its own language. And if you've never learned chemistry before, if this is the first time you're learning it, you learn it right. Okay, so that way you don't make mistakes later. All right, so I know we all have our handwritings, and some of us like to write in caps, some write in small cases all the time. But for chemistry, you have to follow the rules. Okay, otherwise you can make a mistake. Okay, or you can send the wrong message. So you might want to just change your writings a little bit and make it clearer and make it exactly how I would like you to write. So for example, when we say this is a small m, please make sure this is a small m. Okay, and not a capital one. And this L should be a capital one. Although you will see that a lot of times, a lot of textbooks, they will interchange the L to a small one also. Okay, so they have a capital one and they have a small one. Especially when they write something like milliliter, sometimes they write it like this. I will always write it like this. Okay, because technically the liter is capital L. All right, so you will never see me do this. I will always do this. So consistency is very good. It's really important. Also because there are some of these units, and especially M, okay, you will encounter so many M's that it's, you really have to keep a track of what M is this. Okay, is this M for meters? Is this for mass? Is this for miles? What is this for? Okay, so you have to keep a track of that also as we keep going on. All right, so this is for the SI units. Pounds is LB, ounces, OZ, right? Yes, okay, all right. Inches, IN, FT, MI, MI. These two are fine. Gallon is GA. I don't know if it's capital G. I think it might be capital G. GAL. Is it GAL?
I think it's GAL.
GAL. And quarts would be?
QT.
Wow. Okay. You guys are good in the non-SI. Good for you. All right. Okay. So these are the non-SI units. Now, the advantage of one over the other, I think we kind of talked about it a little bit last time also, is that the SI units were all based on the unit of
10.
10. Everything is based on 10. So if you go from a smaller unit to a larger unit, it's just have to multiply or divide by 10. Okay, that's all you have to do. However, in case of the non-SI unit, that doesn't happen. There is no uniformity. Okay, so for example, how many ounces in a pound?
16.
How many inches in a foot?
12.
Why not 16? Who knows? Okay, or why not 12? Because we are special. Okay, all right. So it just means that it gets more complicated and it gets harder to remember. Okay, when you start doing all these conversions from a small to a large one. Besides, here's the other thing about some of this, is that unless you are experienced with something, like inches and foot, unless you really know what you're talking about, you may not know which is the larger unit, right? Mm-hmm. Dozen. What is dozen?
12.
What is score?
Oh, isn't it 20?
Isn't it 20? Is it 20? It is 20. It is 20. Okay, yes, question, answer, right, very good. Okay, it is 20, but there was only one voice compared to what dozen was, right? Do you see what I mean? So unless you're exposed to a certain unit and you know about it, you don't know. Okay, century people know by now, decades people know, but otherwise you wouldn't know. So which means if you're not exposed to these kind of units, you would not know which is larger than which one. Okay, that kind of thing does not happen in the SI units because it's very consistent. Once we say that this is a larger unit, then that prefix stays for everything. All right, so when we say kilo is larger unit, that kilo would be used for everything. It can be used for liters, meters, seconds, whatever it is. Okay, it's the same thing. So that's the nice thing about the SI units. Are we good so far? Okay. So then on page number something something, let me see which one. This is still chapter 1. It's page 19. If you have the summary, that's good. If you have the PowerPoint, that's fine too. If you don't have either and you have your textbook, then you will find it over here. If you don't have anything, what are you doing? Okay, you should have something at least with you. Okay, but anyhow, so there is a little table over here that gives you the size of the units. Okay, of which one is larger, which one is smaller. I like to keep it consistent a little bit for myself. So I have a base unit that I call, and my base unit is 1. From 1 I go higher, and then 1 I go lower, okay, from there. And what that means is I'm working with units of 10, that's all I'm doing, okay? So which means higher would be going to 10, 100, 1,000, and don't write this yet, so on and so forth. Below that would be 1 over 10, 1 over 100, 1 over 1,000, things like that, right? So we're going smaller in these cases and higher in these cases, all right? So there are certain quantities that you need to know. You don't need to know all of these, okay? So I'm going to write the ones that are the most common ones. But this is the kind of system that I'm following. I'm going to erase this. 10 to the power of 3, which is 1,000, is kilo. 10 to the power of 6 is mega. 10 to the negative 1, which was 1 over 10. Okay, that is deci. Very good. 10 to the negative 2, centi. 10 to the negative 3, very good. Guys are so good. 10 to the negative 6, negative 9, 10 to negative 12. So this is micro, nano, and pico. Okay, guys are doing really good. Okay, so then let's go ahead and write their one letter abbreviation. So for mega is capital M. Again, we encounter all these M's so many times. Kilo is capital K. No, D. Centi is C. And milli is small m. Micro is
squiggle.
Okay, it's a U with a little tail. Okay, that's micro. Nano is simply N, and pico is P. Yes.
In the
All right. There. Good. Thank you. All right. Which means I've been teaching wrong for the last 17 years. Okay, that's fine. It's fine. I don't think they figured it out yet. Okay. All right. The base unit is what I consider to be all of these. These are the base units, okay? Without any prefixes at all. So grams, meters, seconds, Kelvin, liters. These are the base units, and from there you can go either higher or lower, okay? So when I was saying to you about this, how many ounces in a pound? It means the larger unit here is pounds, okay? Because that's a lower number. And so you have more of ounces in pounds. So here when I say this is my base unit and I have kilo over here, it means I have more of the lower one in the higher one, okay? So once you know these prefixes, then you're all set, okay? So whether you're dealing with meters or liters, it should not matter, okay, at all as to what's going on. So here if we have, say, meters, And then I say I have a kilometer, that means I have 1,000 meters in that kilometer. Are we good? Okay. One of the things that I would urge you to do as you're doing all of these calculations and learning about the units is talk to yourself. Okay? When you set up the problems, and we're going to set up some problems today, when you set up the problems, you should talk to yourself and see if it makes sense, and eventually it's going to start making sense. Okay? So for example, you will say, you know, I have 1,000 meters in a kilometer, not 1,000 kilometers in a meter. All right? And hopefully as you're learning your units, you will know that you can't have 1,000 kilometers in a meter. It's not possible. Okay? Because kilo is the higher unit. Right? And when you have a higher unit, you can't have a larger number with it. Okay? That doesn't go together. So you'll see what I mean as we go on. Okay? But anyhow, so these are your prefixes. Regarding the non-SI units over here, I usually give you those ones, okay, because I can't remember all the conversions myself. So if I need you to convert one unit to another unit, I will give those conversions to you. The SI units, you have to know those conversions yourself, okay? So please memorize this part at least. Now, there are some conversion factors given here. I think I already told you this part, okay? So there are some conversion factors given here. The problem with these conversion factors is that you may not have these in the exam. So I would not memorize them. Okay, there is absolutely no need to. Once you start doing the problems and you remember them on your own, that's fine. Okay, but don't try to sit down and memorize this. I have so many other things for you to memorize this semester. Okay, so this is not one of those things. If you have to memorize, this is what you should memorize. Okay, if you already don't know this, then memorize this one, okay, as to which is the larger unit, which is the smaller one. What you'll have to do is you'll have to convert from one unit to another unit. It's a very common thing, okay? And there was an explosion from NASA about 15 years ago. It was a rocket explosion, and that happened only because people did not convert the unit. It was a joint project between Europe, I think Britain, and USA, and they used different units, and because they did not convert properly, there was an explosion. Something happened in there, and it was just because of unit conversions. Okay, that somebody did not look at that. Okay, because what I was asking you before about I'm 50 doesn't mean a thing. Okay, unless you put something behind it, years, pounds, kilos, something behind it, that number has no meaning whatsoever. So somebody dropped the ball on that one, and so there was an explosion. But in any case, we're not going to drop the ball. We're going to use units all the time. Okay, so anytime you have a number down, you have to have some unit with it. And you can call me on that too, okay? Even when I'm writing on the board, call me on that. So what you'll have to do is you'll have to convert from SI to SI. You will also have to convert non-SI to SI, okay? Back and forth, whichever way. I can ask you to convert from nano to kilo all the way through, or I can ask you to convert nano into ounces, okay, whatever it is. I will give you those conversion factors, which is why there's no point memorizing what's at the back of the book, okay? Because you have to concentrate on whatever I give you, especially in an exam, okay, where you don't have any conversion sheets with you. So I will give you that conversion factors, and you have to work within that, okay? The only ones I will not give you is the SI units. Are we good? Okay, so that's what you have to work towards. All right, so let me see if they got my thing working over here. And by the way, I forgot to mention, there is also a conversion sheet, I think, on the website, okay, on my website, the green one, okay? So it's an Excel sheet, and you can download that, and it is still Excel, it's not PDF, which means you can add things if you want, okay, to it. You can add any other unit that you want, that you think you use. Please do me a favor and never, ever, ever use any conversion app to do any of your calculations. It's totally not worth it. Okay, to do that. I have an app also, but I don't use it for calculations. Okay, when I do my calculations for class, I sit down and I just go one by one by one by one. Okay, good. So do that. All right. And this is the practice you should definitely do. Okay, so that you know whether you're comfortable with this or not. So 9.21 times 10 to the negative or positive? Negative. It's a small number. So 1, 2, and 3. So are we good then? Yes? Okay. So I did a positive one before for you. 9.21 times 10 to the negative 1 times 2 to the negative 3. Okay, now I want to set up one of these conversions for you. Okay, so let's talk about unit conversions, because that's what we need to do a lot of. Okay, so let's say, let me see what I have over here at the back. And so we have inches to centimeters. Okay, so 1 inch is equal to, what am I doing? 2.54 centimeter. So you can have different kinds of conversions. You can have a very short conversion, you can have a long conversion as well. Okay, so for example, a short conversion would be convert 3.20 meters to centimeters. That's within the SI units. Okay, that's what you have to do. So in this case, what you will do is what we call dimensional analysis. I want to talk a little bit about dimensional analysis. Okay, it is something very, very American. Okay, completely. I had not heard about this thing until I came here and I started teaching. And actually, in the last 15 years, I think it's become even more. I don't know. Okay, or maybe I didn't pay attention to it before. Okay, but anyhow. But it's very, very good. It's very easy, okay, to do once you get the hang of it. And you can do very complicated problems very easily, provided you follow your units, okay, in this case, dimension analysis. For those of us who are from a different country, we tend to use what's called the ratio method, okay? I don't care whether we use dimension analysis or whether we use ratio, okay? I just want to get the right answer. That's all I care about. So if there is some way that you are comfortable with, that you want to do the conversions, you do it. It doesn't matter, okay? Just make sure that whenever you do these calculations, you show all your work, all right? So if something is wrong in your calculation, and if your answer is wrong, and we need to sit down, and we need to talk about what happened and where it happened, you should be able to look at your work and say, oh, that's where I went wrong. Okay, so make sure you write all your work as you're doing this. And dimensional analysis really helps to sort that out. Because all you have to do is you have to look at your units and then set up your problem. Okay, so from here I'm going from meters to centimeters. So I write down that this is what I need to do. And then each of my arrow becomes a multiplication sign. Okay, so in this case there is only one arrow. And so I'm going from here to centimeters. So what is the unit I need to get rid of? It's meters. And so I divide it by meters. And how do I get this? Is because there is a conversion factor from meters to centimeters and centimeters to meters. And how do I know that? Because I'm so good. I just memorized all my SI units. Okay? So now this is where you need to talk to yourself, because you know that in 1 meter there are 100 centimeters, right? Okay, this is where you need to talk to yourself, because now once you start putting numbers in there, that's when the problem is going to rise, because you have to put that in the right place. 3.20 is not hard, because that's your starting point, okay? You always start with what you know, and 3.20 is what you know. Regarding these two over here, going from meters to centimeters, you can look at it either way, depending on what you're comfortable with. And so in 1 meter, I have 100 centimeters. That's how I talk to myself when I do these things, okay? If you feel like you're lonely and you feel crazy talking to yourself, sit with a mirror, okay? So you feel like you have somebody, okay, that you're talking to. Are we good? Now, that 100 centimeters there, how many sig figs in that 100?
3.
1. Okay, and very honestly, it doesn't matter. Okay? In your conversion factors do not matter at all. Okay? Your data is what's important. So your data is 3 significant figures, okay? And your final answer should then be in 3 significant figures. Okay? That's all there is to it. Good? So when you multiply this by 100, you should have 320 dot. And then don't forget to cross out your units and then write the units at the end. Okay? That's what I look for when I look for your work. And please, do not separate the lecture from the lab. Whatever you learn in the lecture, you have to project that in the lab also. So when you take your data, okay, when you write down your data, make sure you write the correct significant figures in that data, make sure you write the correct units. When you're done doing the calculations, make sure you bring it down to the correct significant figures, okay? Your calculator is not the master of you, you are the master of your calculator, all right? So if it gives you 8 numbers, doesn't mean it's 8 numbers, all right? You bring it down to whatever you need, not the calculator. Are we good?
It would technically be wrong if you didn't put the decimal point in, correct?
Yes.
That would make it
Yes. So you have to put the decimal in there. Okay, now from inches to centimeter. How about if I asked you to convert about, let's say, 29.2 inches to meters? And that's the conversion factor I gave you. This is in an exam setting, okay? If you have your textbooks, you can open up and you can find the conversion unit of an inch to a meter. No problem. That means you only have one conversion. But now since I didn't give you anything in the middle, now you have to go from inch to centimeter to meter. So now you have 2 things to do over here, okay? 2 conversion factors to use because I didn't give you much choice. And that's going to happen, okay? That you will be given limited number of conversion factors and the rest you have to decide what to do. So again, these 2 are going to be multiplication. So I have a number here with inches, multiplication, whatever, multiplication, whatever. Okay? I look at what unit I'm starting with. The first thing I set up is my units. Okay? So I'm starting with inches and I have to convert to centimeters. So inches goes down, centimeters goes up here. The next is centimeters to meters. So centimeter goes down here, meter goes up here. This is my final remaining unit. So I'm good to go, right? Unit-wise, I'm ready to go. Number-wise, now let's put in the numbers. And let's get a different color. I have a different color. So I have 29.2 over here. Centimeters to inches I'm given over here, so I don't even bother thinking too much. I don't have to, okay? Because the number in front of inches is 1. The number in front of centimeters is 2.54. Do not mess with that. Do not change anything. Just leave the numbers as they are. The centimeter to meter is SI conversion, so you have to know that yourself. And again, 1 meter has 100 centimeters. My final answer should have how many significant figures? 3. Okay, because that's my data. My data is in 3 sig figs, so that's what my answer should be in also. That's how you set up a problem. Okay, so you can do the calculation yourself. We're going to take a pledge today. Okay, we're going to follow it through for all our classes. So you ready for that? Ready for the pledge? My pledge is that I will never put 1 in my calculator. Got it? Okay, good. So this one you don't need to put. Don't waste your time. Okay? We'll never do that. So do the multiplication of these 2 numbers divided by 100. Done. Okay? Don't waste your time with ones. Okay? Follow that through if you could for me. All right.